173, 174. What do we see that I can help you with? Yes. 9? Cool. Good one to ask about.
That was literally.
That was the one you asked, right?
No, mine was 8.
8?
Oh, yeah. No,
Okay.
wait. Yeah. No.
All right. So problem number 9. We want to use what the slope is in number 8. So number 8 slope is this. And then we have a y-intercept of -9, which is basically the point 0, -9. But we also know the y-intercept, that's our b value. And then we have the slope of this. And we want to find the equation that is parallel. So we know that a parallel slope has to be the same slope. Okay? And then we want this in slope-intercept form. So slope-intercept form looks like y equals mx plus b. And here's the nice thing. Because we know the b value right now, we can just plug that directly in. And because we know the parallel slope, we can plug that in. So we get y equals 2/5 x minus or plus -9, either way. So that is the slope-intercept form that has both of those characteristics in there. Does that make sense? Cool. What else do you have, my friends? 10? Okay. Number 10. Find the equation line that's perpendicular to number 8. Okay, so I know that my slope from number 8 is this. That means my perpendicular slope is going to be the opposite sign. It was positive, now it's going to be negative, and it's going to flip over. So that's the perpendicular slope that we're going to use. And it goes through the point 44. And it just says find the equation. So if it says find the equation, we can just use point slope, which is this, and then plug in what we know. So I'm going to plug this in here, plug this in here. Realize when they go in, if they were positive, they become negative. If they were negative, they become positive. So I'm going to get y minus 4 equals my perpendicular slope, which is -5/2, and then x minus 4. So that's my equation.
So whenever it's perpendicular, you flip it.
Perpendicular slopes are opposite sign, so positive or negative. And then the fraction flips over. It was a whole number. You can make any number a fraction by putting over 1. So like if your slope was 3, then 3/1 is the same thing as 3. And the perpendicular of 3/1 would be -1/3. Yeah.
Number 8.
8. Number 8. Find the equation in slope-intercept form. So slope-intercept form is this. That goes through the point 7, -1, and has a slope of 2/5. Okay, so first thing I need to use is point slope, because I don't know the y-intercept. So point slope is this equation. So this is my x1, this is my y1. So I'm going to get y, that was a -1, so when I plug it in there, it becomes a +1. My slope is 2/5. X, that's a +7, so when I plug +7, that becomes a -7. Okay, so then I want to make it y equals mx plus b. So that means I'm going to distribute over the parentheses. 2/5x minus 14/5. Is that okay so far? So then I'm going to subtract 1 from both sides. So I get y equals, because those cancel, 2/5x. And then we have to figure out what this is. I have -14/5 minus 1. Well, 1's the same thing as 5/5, so now we have a common denominator. So that gives me -19/5. And good luck plotting -19/5 as a y-intercept. What else do you see with my hiccups? How much? 12? Yeah, we're going to do that one as a class. So the quiz tomorrow I won't have a word problem on, but it's important that we know how to do the word problem itself. And yes, some of the word problems are completely dorky, but let's just walk through it. Harold rides his bike to school. Is that anything mathematical that we need to know? Or just creating a story for us, right? 10 minutes after he left, he was 11 miles away. So 10 minutes after he left, he was 11 miles from school. 20 minutes after he left, he was 9 miles from the school. So that means he is riding towards his school. Agreed? Because if at 10 minutes, after leaving 10 minutes, he was 11 miles away. After 20 minutes, he was only 9 miles left. So he's getting closer and closer to school. So it's like this. His home is here. His home's here. His school is here. So he's riding his bike to school. That's what we said in the original problem. Okay, so as you ride towards your school, you should have a lesser and lesser and lesser distance. Okay, write a linear function that models Harold. Okay, so the first thing I'm going to do is find the slope Okay, so I'm going to label this x1, y1, x2, y2. So we have 9 minus 11 and 20 minus 10. So that's negative 2 over, did I do that right? 9 minus 11, negative 2. 20 minus 10 is 10. So I'm going to reduce this fraction. So this is basically his rate of change. By definition, that is the slope. Okay? Okay, so far we know that. And then what we're going to do is we're going to find the equation. So I'm going to use point slope. And being I already labeled this x1 and y1, I'm going to plug those values in. I'm going to ignore the 20, 9, and I'm also going to plug the slope in. So I'm going to get y minus 11 equals negative 1/5 x minus 10. So let's write the linear equation in function form. Okay, so function form means it's going to look like this. Okay, so I want to now convert something that has y with something with it and a parentheses to something that doesn't have parentheses and has y by itself. So I'm going to distribute the 1/5 over. So I get negative 1/5 x. Negative times negative is positive, so that gives me 10 over 5. 10 over 5 is the same thing as what number? 2. Then I'm going to add 11 to both sides to get y by itself. So I get y equals negative 1/5 x plus 13. Okay, so that is the answer to A. Okay, so let's view this as a dual screen on. Hopefully it'll all fit. Yes, it does. Good. Okay. All right, so it looks a little small, but I think we can still comprehend it. Letter B. What is the y-intercept and what does it mean in this problem? Okay, so B, what is the y-intercept? So the y-intercept of this problem is going to be positive 13. So that's 0, 13. So what does it mean in the context of this problem? He lives 13 miles from school. That's kind of a far bike ride to school, but hey, I guess some people can do that. Okay? Because at time zero, means that's when he is at home. Okay? It says Harold rides his bike to school. So I think we're assuming that he is at school or at home. Okay? So at time zero, he opens up his garage, he's sitting at home. He gets on his bike, starts riding. 10 minutes later, he knows there's a 13-minute ride. 10 minutes after he starts riding, he's got 11 miles left. He's already ridden 2 of the miles. And then 20 minutes after he left his house, he is 9 miles. So he's basically riding at the slope that they say, 1 over 5. Okay? What is the X Intercept and what does it mean in this problem? Ooh, this is a tougher one. And again, I'm not going to have this on the test. So the X Intercept, that means where my y is 0. Okay? If I plug into my equation, I have this. And if my y is going to be 0, So subtract 13. Oh my gosh. Multiply both sides by -5. Let's see. 5 times that is going to give me 65 equals x. So, what does our x value mean in the very first thing at 10, 11 or 20, 9? What does the 10 and the 20 mean? Minutes. So this is also an x value. So 65 takes 65 minutes to get to school. Yeah, an hour and 5 minutes to get all the way to school on a bike. Hopefully it's a nice ride. Hopefully it's nice weather, things like that. But we're not too concerned about that, but I'm just trying to portray what that means. So the X-intercept in the context of this means at 65 minutes, he has 0 miles left to school. Okay, so it takes him 65 minutes to ride all the way to school. Okay, it's a longer distance. I mean, I would say most of you have done something for 65 minutes. It might not have been riding your bike. Hopefully it is. Hey, you see a couple phones out. I'm so sorry that I'm taking away from your education. Oh, wait a minute. Your phone's taken away from your education. Earbud out, please. Thank you. Letter D. What is the slope and what does it mean in the context of this problem? So the slope we found originally was -1/5. So this is the y direction. This is the x direction. Okay? So this means our buddy Harold, that's an old school name, isn't it? He rides 1 mile every 5 minutes. Okay? So he gets, he's on a bike. Is 1 mile in 5 minutes fast on a bike? Well, no. Maybe, I don't know, maybe he's dawdling a little bit. Who knows? And we're assuming he's riding at a constant rate of speed. And then E, how far is he from home after riding 30 minutes? Okay, so 30 minutes is an x value. Okay, so if I take my equation, which is this, and I plug, because everything's in minutes, if I take this 30 and I plug it in for x, I have y equals -1/5 times 30 plus 13. That's going to give me -6, I believe, plus 13. So after 30 minutes of old Harold riding his bike, he's 9 miles away. He's 9 miles from where he started. I guess he's 9 miles from home. And after how many minutes will he be 6 miles from school? So this is a y value. So I'm going to plug that into my equation. So I have 6, if I can make a 6. 6 equals -1/5 x plus 13. Subtract 13 from both sides. So -7 equals -1/5 x. If I multiply each side by -5. Let's see, did I do that math right? 6 minus 7, 1/5 x. So x equals -5 times -7 is 35. So 35 minutes after Harold left his house, he still has 6 miles to go. How far total did he have to go? He had 13 miles to go. So after 35 minutes of riding his bicycle at a constant rate of speed, he's ridden 6 miles. Wow, aren't you glad that's not going to be a question on the test tomorrow?
Wait, are you sarcastic?
I won't have that on the quiz.
Oh,
No, I mean that's kind of a lot of meat and potatoes. And here's a hard thing. If I give you this kind of question, let's say you got this incorrect. Let's say that was incorrect. That equation gets applied all the way through the problem. So, So what we would do probably on that problem is we would probably give it to you in portions. We wouldn't give it to you like A through E. We'd probably be like, hey, what's the equation if this took place? And like, hey, we found this is the equation. This is a different equation that he's riding his bike. You know, what would the Y-intercept mean in the context? So we would break it up for you. I mean, that is an A through F.
it's like a complete breakdown of the problem.
Yeah, I mean, there's a lot to that. I think there's a lot of critical thinking that goes with that problem. I don't think it's a bad. I mean, we've definitely given you much worse word problems. You know, especially the one about making candles. I'm sorry, I think that was the most boring problem I've seen in 26 years of teaching. But I think this is a good critical thinking question. I think it's good for discussion. Okay. All right. Hey, I'm going to do something off the cuff. Can I do something off the cuff? I need you to get your phone out. Deal? Get your phone out. And go to the App Store, please. I need your phone out, and I need you to go to the App Store. Does that make sense?
Yes.
I have a free app that I want us to load.
Is it a remind?
No, it's not a reminder. No. I'm not that goofy.
Is it like compass or anything?
No. So, I would assume you all know where the App Store is at on your phone. Not Photomath. Not doing Photomath. Though Photomath is in the App Store.
Oh yeah, like
All right, let's see. So what I would like you to find is an app called Desmos, Desmos.
Oh, I hate that.
oh, I use this before.
Okay, and I'd like you to add that app to your phone for me, please. It is greenish, yes, yeah. Let's see. Hang on. I gotta pull it. I got on my phone. Let's see. I loaded it on my phone earlier. It's greenish. It looks like almost kind of like it's green with a white curvy and then a parabola. Yeah, graphing calculator one, yeah. Okay.
I have a real journal.
Yeah, there's a real graphing calculator. But did everyone find this?
Yeah.
And friends, is it loading by chance? Okay. Okay, now I'm showing you this because one, I'm pretty sure the majority of you for the next couple of years will have your phone with you. Now I realize there's cracked screens and things like that take place, right? Okay. So I want to kind of be goofy. Can I be goofy for a little bit? Okay. So I'm going to ask, so I'm going to go into on mine on graphing calculator. So I think your original screen is going to look like this once you've loaded it. Does that seem about right? Okay. So we just need to find a few things. So on the computer, it's slightly different because one, it's a larger screen. You guys have a smaller screen. Let me close out of my Desmos completely and see what happens. Close a few apps. All right, so Desmos, I'm just trying to see what it takes me to the home screen. So do you have kind of an XY axis on the top, and then it has like a blinking cursor, and you have some stuff below?
Yes.
Does that make sense? Okay. So what I want us to find, and I have to find it on my phone, make sure I can find it. Okay. I'm going to look for, find the plus button and find the table. plus, and then table. And it'll say Y1 and have that dotty looking, I don't know if yours will be green, you might have a different color to default it to. Do you have something like that? Okay. So, I am going to tell you that I am 69 inches tall and my shoe size is size 9. Okay? So, if I plug that in on my phone, so if I scroll way out, if you scroll out hitting the minus button, you'll see I have a dot way over here. Agree? Now, I want to add, so once you do that, you hit enter and go back to this one. Let's see. Would anybody be willing to tell me what your height would be and your shoe size? If it's a girl who's telling me, add 2 to your shoe size because we'll go with my Key. What, you know how tall you are? How tall? Okay, just do you know what it is in feet and inches and we can convert it? Are you 6 foot 1, 2?
Says 72 inches.
72 inches? So Keegan, would you be willing to tell me what your shoe size is?
Yeah, 13.
13. Okay, good. Okay, so far up on our thing, we have both mine and Key's height and shoe size. Okay. Would somebody else be willing to give me their height in inches and their shoe size? And if it's a female, please tell me two sizes bigger, because for whatever reasons, guys and girls' shoe sizes are not the same. 67? Size 9.5, 9.5.
Mine says 73.5.
73.5? Oh, okay, we can change that. 73.5. And size 13 is still correct, right?
So do we have to do this if you're doing it for?
No, I'm just going to walk you through. We're just playing around a little bit. I just want to, if you can figure out how to plug those numbers in on your phone, that'd be fantastic. Would somebody else be willing to give me their height in inches and their shoe size? Any of my girls? I'm not asking for weight. I don't do that. Anybody? Anybody else? Yeah. Just your height in inches? 5'2", so that's 62. And then what's your female shoe size? 8, so that would be a 10 as far as guys go. A 6, wouldn't it? Okay. Got to subtract. Okay, I'm glad I have smart people here. Anybody else willing to give me a little information? Okay. Well, I think we have enough. So what I'm going to do is I'm going to go down, and you can do this on your phone as well. If you have the data plugged in, once you plug the data in, you can click down to the next thing. And I need you to find this. And this is pretty cool. I'm going to do it real quick, and I'm going to tell you where to find it. Oops, Y1 plus B. Okay. So what this is showing up on the screen is you recognize y equals mx plus b, correct? You recognize that y equals mx plus b? So that tells me we have a slope of 0.58 and a b value of negative 30. Okay? So somebody jot that down for me real quick, because I'm going to go back to my screen. So right now I'm going to go to view. I'm going to view. We're going to go to single page off. All right, so far what I have is we have some data, and I have y1 tilde mx1 plus b I plugged in, and I think I have, let's see, 0.58 plus our B value. Our B value we say is negative 30.1. Okay, so this is by our data of what we collected. This is the line of best fit that's going to work. Okay? Now it's important for you to know where to find this information. Okay? On Desmos on your calculator, you can find the Y pretty easily. It's on the home screen. And then the tilde, and then you're going to hit number 1 next to it. And then you're going to have to find tilde. So tilde, you hit the ABC, I think. Yeah, ABC, and underneath the B and the N is the tilde. And then M is just like regular M. And then I'm going to say X, and I'm going to call that X1. And then the plus sign is on the number plus B. Okay, so can everyone find that on there? Okay, and it's important that you have the tilde. That tilde is important to have. Okay, the Y1 and the X1 are labels of our graph, of our grid. The tilde says we are going to make an equation. This isn't tilde in geometry means it's a similar shape, meaning all the angles satisfy each other, but the size doesn't matter. So, but tilde in Desmos lingo is going to say find the line of best fit. So, my friends, this is my slope. So remember the slope I can make as a fraction. Now, I'm going to kind of go no math. No in math is I'm going to make 0.58 over 1 as a slope. Okay? So if we go back to our thing, our height was the X value and our shoe size was the Y value. Agree? So height in inches is the X value and shoe size, as far as shoe sizes go, is the Y value. So this is what this means. Is this the Y value on top? And is this the X value on bottom? Because is our slope equation this? Okay. So what this means, and this is not official because we only have a couple pieces of data, but our slope in the context of this problem is for every 0.5 inches in height, the shoe size increases by 1. Okay? So, now let me ask you this, my friends. If I were to take all of the freshmen here at Cherry Creek High School and sophomores, we're talking about roughly 1,900 students. Agree? Maybe closer to 2,000. Agree? So that's an awful lot of data. But if we took all of their information, if we ran a survey or y'all sent out a group snap saying, hey, what's your height and shoe size, height in inches and shoe size, and you got all this data back, hopefully everyone's telling the truth. You don't have someone who says, yeah, I'm 116 inches tall. No, they're not. That's way too tall. But this is a real life application of a linear equation. Now, here's the goofy. What does the point 0, negative 30.1 mean? What is our X value? What is our X value as far as our equation goes? It's our height, isn't it? So if somebody is 0 inches tall, then their Y value is their shoe size. If somebody is 0 inches tall, which, let's face it, no one's 0 inches tall, but they would wear a negative 30.1 size shoe. How would you wear a negative 30 point? That's a really small shoe. It's a nub. It's a nub. Yeah, if you're 0 inches tall, we're talking we itty bitty, right? I mean, so friends, let me ask you this: Does the Y-intercept, which this is the Y-intercept, does the Y-intercept sometimes give nonsense? Okay. Now, I've seen some short people at school, and I see some tall people at school. I'd say our shortest person is probably in the 4 foot something range. What do you think? 4'11", so in the 4 foot range, right? Okay, so 4'11", okay. 4'8", okay, so in the 4 foot range, though, right? So we're like in the 4 foot range, all the way up to close to 7 feet. I mean, 6'10". Is that how tall? What's his face is? Booker. Is his last name? I can't remember his first name. Yeah. Isn't he like 6'10"? I mean, that's pretty big range of heights of people. 4'8" to 6'10". That's a lot of difference. Now, I bet you, the person who's 4'8" has a relatively small shoe size compared to the person who's 6'10". I don't think the 6'10" person has a size 3 foot.
I mean, you never know.
He might, be on a balancing act walking down the hall, but you never know. Tall with small.
Well, like not small.
Small, like it doesn't make sense, right?
Like you think they're
Yeah. So it is very possible. So it's not an exact science, but what is that? What is that?
Two of my teammates are the same height. One of them's like 15, and the other one's like 11.
Really?
Yeah, like they're both 6'5". One of them's like 13.
Somebody ringing? Is somebody doing a find my phone? Is that what it is? Okay. Yeah, I remember many years ago. My dad's 6'2", so he's taller than I. My dad and I. This is right before I moved to Las Vegas to take my first teaching job. My dad and I I lived in Arizona, and we went to a mall called Scottsdale Fashion Square. And it was a relatively mellow day. There wasn't a lot of people in the mall. It wasn't like a Saturday or Sunday. We go walking into the mall, and walking out of the mall right towards us is Shaquille O'Neal. Now, my dad's 6'2", so he's bigger than me. My dad looked like an infant compared to Shaq. Shaquille is a big man, and what a nice person. We didn't mob him to say, hey, how about some autographs? I held the door. I was like, hi, Shaquille. And he goes, oh, hi, how you doing? And he chatted with me and my dad for about a minute or two. And then there was a whole mob scene of people like, there's Shaq. And they go running. He goes, I'll see you guys later. And he went. And there was some lady that was waiting in the smallest Honda Civic. And here comes Shaquille and gets into this Honda Civic. I don't know how Shaquille O'Neal fit into the front seat of this Honda Civic, but he got into the little tiny Honda Civic with his girl was waiting for him, and they took off. I don't know who the girl was. Obviously, he would know who she was, I would think. This is before the Uber and all that kind of stuff. We didn't even have cell phones that were much more than the brick. You had this cream-colored thing going, yeah, it'll fit in my back pocket. It's like, yeah, you're going to get scoliosis. You can put a curve in your spine with that in your back pocket. So. I just can't figure out how he fit into a Honda Civic. Oh, he probably put his seat back, tilted it back. He probably took the front seat out and sat in the back seat and had his feet. I don't know. So my friends. So with this I just wanted us to have a little fun with this context, and we're going to play around with it a little bit more. But tomorrow, my friends, we do have a quiz. Now, on the quiz, I have at the top, I have the slope equation, and I have it labeled. And so it says slope equation, And then I have point slope, and it's at the top of the front, which is this. And then I have, so that's point slope, and then I have slope intercept. So, my friends, what I'd like you to do is give me some sort of valiant effort. I'm not going to assign you an assignment, but I would say if you were to go back and take a look at page 173, 173 especially, that was last night's homework, and if you feel comfortable with basically problems 1 through 10, you should be able to do well. Now realize this, I did not work all the problems out, but all of the odd problems are on Schoology that you could look up if you wanted to double check. Okay? So that'll be for tomorrow because we have a quiz tomorrow. And then today's video would have some of the other problems that we worked out. Don't worry about the big word problem though. Just kind of study a little bit. Deal? Everyone good? Yep. All right, when it hits the 58 and about 20 seconds after that, you can go. But don't go at 57.